Let's take a look at Achieve Section 7.5, number 10 with one of our partial fraction problems. In this one, they give you a linear factor that's repeated to the second power in the denominator with the x squared. And then they give you an irreducible quadratic factor, something like x squared plus 25. Each problem will be slightly different, and mine, of course, had a 7 in the numerator. So all of the problems of this sort will be solved very similarly. You're going to take the fraction that you have, and you need to algebraically decompose that fraction into its 3-component smaller fractions. So we know we're going to need a separate fraction for every power of the linear factor x squared, and you're always going to have a constant in the numerator of each of those. So I have a over x plus b over x squared. Now the irreducible quadratic, the x squared plus 25, I needed a linear numerator, so I'll call that the numerator cx plus d. Now what I do is I treat this equation I have here, and I need to solve for a, b, c, and d. So I'm going to go through and multiply by the least common denominator. That's x squared times x squared plus 25 on both sides. When I do on the left, of course, I just get a 7. When I multiply by it on the right, this x cancels out one of the x's in the x squared, and I have ax times x squared plus 25. Then I would have plus b times the group x squared plus 25. And then I would have cx plus d times only the x squared there. Now what I went ahead and did here, and you don't always have to do this, but it helped me see what the coefficients of each term of x was on the right. I went ahead and distributed out and said, well, I'm going to have a times x cubed plus 25x. B was already times x squared plus 25. I'm going to have c times x cubed, and I'll have d times just the x squared. Now I use this equation to solve out for each of the a, b, c, and d terms. The only value that I can let x equal to solve for a term is if I let x equal 0. If I let x equal 0, I know that the a and the c and the d term all cancel because they'll all be multiplied by a factor of 0. Whether I look at this or this, they're all multiplied by 0. But the b term, it's going to be multiplied by 25. So if I let x equal 0, it results in the equation 7 is equal to 25b. Thus I know b is equal to 7/25. So then as I started thinking about how I'm going to solve for some other variables, I looked and I noticed a was the only coefficient of an x to the first term. Notice there's no other x to the first term. So I just said, I know by looking at the left-hand side, the coefficient of x to the first, it's supposed to be 0. So that tells me that 25a would also have to be 0, which of course gives you a is 0. You can similarly see that c is 0 by saying, well, notice a and c are both coefficients of x cubed. I would have ax cubed plus cx cubed. The coefficient of x cubed, it's supposed to be 0. So I know x cubed is supposed to have a coefficient of 0. The only coefficients in the problem are going to be a plus c. Well, I know a was 0, therefore c is also 0. These problems really work out nicely when you start getting a lot of zeros. It makes the integration easy. For the last term here, in order to determine d, I said, well, I know that b and d would be my only coefficients of x squared on the right-hand side. You look on the left-hand side, yet again, the coefficient of x squared, it's supposed to be 0. Well, that tells me that b plus d must equal 0. Then that means d has to be the negative of b. And I know b is 7/25, so d has to be the negative of 7/25. So now I go into my problem. This original integrand, I'm calling I the original problem, it's equal to the integral of all of this. Well, the a term canceled out, so that term's gone. We said b was 7/25. Notice what I did. I said I'm going to factor a 7/25 out of the integral 1 over x squared dx. And then I know that c was equal to 0 and d was equal to negative 7/25. So d is the constant term over this x squared plus 25 please notice I went ahead and factored that out and said, well, minus 7/25 times the constant 1 over x squared plus 25 with respect to x. The first one, I just thought of that as x to the negative 2 power. So the power rule says that's going to be x to the negative 1 over negative 1. The second one, I used a formula from your table of integrals, number 16. It just makes taking the integral of that a little bit easier. You should have recognized it was in the format of an inverse tangent function. And you can see number 16 here. It says anytime the denominator is a squared plus u squared, you can call it 1 over a inverse tangent of u over a. So that's what I allowed that to be. And I just said, well, then that's going to be 1/5 the inverse tangent of x over 5. That's where that comes from, number 16. Plus your constant of integration, of course. Final answer, just cleaning it up. We know this x belongs in the denominator along with the 25, and I made my numerator -7. So -7 over 25x minus, here I'm going to get -7 over 125 inverse tangent of x over 5 plus c. That's a gorgeous problem.